This was the hardest question on the Year 11 Olympiad, and what they're asking is for us to prove that this line here, from A to the midpoint of the line QR, is half of the length of U to T. And all that we're told is that PQAU is a square and RSTA is also a square, and they share this point A. So how are we going to go about solving this problem? So one idea that you might have is to try and create some kind of level of symmetry where we could join A to the midpoint of UT. And this was my first thought. If anyone can do it this way, I'd be very impressed, but I did this, looked at it for 20 minutes and got completely stuck, and a different approach is going to be necessary here. Because we know that this line would be the same length as this line, because that's what we're being told to prove. Of course, we can't use that in our proof. Sometimes it's helpful to know what you're trying to find, to almost work backwards and find other related things. But in this case, it didn't give any insight whatsoever. So I did what good math teachers do in this situation, which is to ask another maths teacher. And they suggested that what often is the case in these types of problems is when you have a triangle with a line from one of the vertices to the midpoint of the opposite side, it's to double that line. And this might sound strange, but we're going to extend this line so it's the same length of AM, but from M to, say, a point B. Why on earth would we do that? Well, we're going to join up Q with B and R with B. And what shape do we have here? If you said a parallelogram, you are correct. So this midpoint, M, would be the midpoint of this whole parallelogram now, where the diagonals are Q to R and A to B. So these lines parallel, and the same with these. But how does that help us? Well, now what we have is we can see with this triangle AUT and the triangle RAB, they both share the smaller square side and they both share the larger square side. So that's going to be helpful. And if we can show that the angle between those two sides is equal, so these two angles, ARB and angle UAT, if those two angles are equal, then these two triangles are congruent, and that would mean that AB is the same length as UT, so AM, which is half of the length of AB, would equal half UT. That's going to be our strategy. So how are we going to show that this angle here, ARB, is the same as the angle UAT? The reason that we're introducing these lines and this parallelogram is so useful is now we can use parallel line properties. So we know that ARB and QAR, so this angle here, QAR and ARB, what kind of angles are they? They're angles in between parallel lines and they are co-interior. So they sum to 180. And because these are both squares, we've got two 90-degree angles here. So QAR and UAT will also sum to 180. So if we call this X, this would be 180 minus X. So we have proved that ARB is equal to angle UAT, for the triangle UAT is congruent to triangle BRT. And now these lengths are equal, and thus half of one of the lengths is equal to, so AM is equal to a half UT. So we have proven it, and that is how you prove that AM is equal to a half UT. And the general problem solving strategy here that is useful is that if ever you have a line from the midpoint of one of these triangles to the opposite vertex, double it to make a parallelogram. If you like that, let me know in the comments.